So the first question is from units and measurements. Okay, so this is capsule classes part number 4. Let's get into the question straight away. The length, breadth and thickness of a metal sheet are 4.234, 1.005 and 2.01 centimeter respectively. Give the area and volume of the sheet to correct number of significant figures. This is the question. So we have to calculate the area of a box and the volume of the box. So let's calculate the area first. For that, what all things they have given, let's write it down. They have given length first of all, correct? They have given length which is equal to 4.234 meter. 4.234 meter. They have given breadth which is 1.005 meter. 1.005 meter. They have given thickness also, which is 2.01 centimeter. So in the given number of parameters, length is having 4 significant figures, breadth is having 4 significant figures, thickness is having 3 significant figures. So if you do any kind of multiplication or division procedure, what you have to make sure is that the final result should have the least number of significant figures as that of the given numbers. Okay, the final result should have the least number of significant figure as that of the given numbers. Which are the given numbers? Length, breadth, thickness. In this, which one is having the least thickness? Which one is having the least number of significant figures? Thickness is having the least number of significant figures, and it is 3. So the final answer should have 3 significant figure. Okay, so let's take the area. So how will you calculate area of a box? It's a 3-dimensional box. We have length, breadth and thickness. So what will be the formula? Area will be equal to, there will be 2 sides with area, length into breadth. There will be 2 sides with surface area, breadth into thickness. There will be 2 sides with surface area, thickness into length. Understood? Because you just can just visualize it in your mind. There will be 2 areas. There are 6 faces, right? So 2 areas will be having area, length into breadth. 2 faces will be having area, breadth into thickness, and 2 faces will be having areas, thickness into length. Substituting values for LBT, the correct answer you are going to get is 8.7206. But we have to round this answer to proper significant figures, because the rule says that the final answer should have only minimum significant figures as that of the given number, which is 3 significant figures should be there in the answer. So the final answer become 8.72. Okay, 8.72 should be the final answer, and the unit is meter square. Got it? Now when it comes to volume, what is the volume of a box? Volume is simple, which is length into breadth into thickness, LBT. Length into breadth into thickness. So substituting the values of length, breadth, thickness, the actual answer you are going to get, I'll write first, 0.0855289 meter cube. This is the actual volume you are going to get, but the answer once again should have only 3 significant figures. So final answer will be 0.0855 meter cube. Understood? Because the after 5 the number is 2, so it will not become 6, it will end up in 5 only. Okay, so the answer will be 0.0855 meter cube, and the area will be 8.72 meter square. I hope you should first of all you should know the entire rules of significant figures, rounding. Okay, I hope you got the problem. Okay, Next question is, a body travels uniformly a distance 13.8 plus or minus zero point 0.2 meter. Okay, there is an error in the distance. In a time 4.0 plus or minus 0.3 seconds, there is an error in time 2. We have to calculate the velocity with error limits. And what is the percentage error in velocity? Okay, so that's what we have to calculate. We have to calculate the percentage error in velocity as well as the velocity itself within error limits. So how can you calculate the error of how can we calculate the velocity as well as the percentage error in velocity? So let's write a distance first. Distance s equal to 13.8 plus or minus 0.2 meter. Okay, this is the relative error part, 0.2, and time is given as 4.0 plus or minus 0.3 second. Fine. So what all things first you will understand if you see such a number. So one thing you have to understand is that the first part is the magnitude and the second part is the error. Okay, that we all know. This is the error part and this one is the magnitude part. Something else you should know is that we are taking a measurement, and that measurement is having a tolerance of this error part. So it can be either, the real value can be either plus 0.2 or it can be the real part can be within the tolerance level of plus 0.2 or minus 0.2. As well as the time is also, the real time measurement value will be within the tolerance limit up to 0.3 seconds or up to minus 0.3 seconds. That's what we should understand from these figures, whatever. Now we have to calculate the velocity. So what is velocity? We know velocity equal to displacement by time. So first you have to do calculate the magnitude. 13.8 divided by 4.0, you get an answer which is 3.45 meter per second. 3.45 meter per second is the velocity, and we have to calculate the error part of the velocity. How will you calculate? Delta V by V equal to, errors will be always added, so delta S by S plus delta T by T. Delta S by S plus delta T by T. Now it's all given. What we have to calculate? Delta V only, correct? V we already found out, which is 3.45, equal to what is the error in the displacement? It is 0.2, divided what is the magnitude? 13.8, plus error in time is 0.3 divided by 4.0, from which you can calculate delta V, and that value what you are going to get is delta V will be equal to, after doing all this process, you get an answer which will be equal to approximately 0.3087. 0.3087 is what you are going to get. And the next step what we have to do is that some rounding methods. So 3.45 you can round to 3.5 meter per second. Remember the rules of rounding. And the error part, how will you round? It should be round to 0.31. 0.31, and the final answer, that is delta, that is velocity. How will you write velocity now? 3.5 plus or minus 0.3087. 3.5 plus 0.31 plus 0.31. That's how you should write the velocity now, plus 0.31 meter per second. Okay, that comes the velocity part, and then comes the percentage error in the velocity. Percentage error in velocity will be, percentage error will be equal to delta V by V, that is relative error, which is delta V by V into 100, that is percentage error, which is equal to, if you do that calculation, you get an answer which will be plus or minus 8.95 percentage, which you can round up to plus or minus 9 percentage. That's the percentage error. So hope you understood how we do problems regarding errors. It's very important, and nearly 3 questions might come from units and measurements. Nearly 3 questions, so we'll be very careful. One question will be from errors, without doubt. One question might be from significant figures and rounding, and one question will be from dimensions. Okay, dimensions is the easiest topic, so I'm not giving you a question from that part, but be careful with significant figures, rounding as well as errors. Okay, so this is another question from chapter units and measurements. The question, let's see it. In an experiment to determine acceleration due to gravity, the length of the pendulum is measured as 98 centimeter by a meter scale of least count of 1 centimeter. The period of swing or oscillation is measured with the help of a stopwatch having a least count of 1 second. The time period of 50 oscillations is found to be 98 seconds. Express the value of acceleration due to gravity with proper error limits. So this is a question which we have to calculate the value of acceleration due to gravity with proper error limits. So first of all, we should know the formula of the time period of a simple pendulum. Time period of a simple pendulum is T equal to 2 pi root of L by G. Okay, that is the formula. Now, time period of 50 oscillation is given as 98 seconds. See, it's given in the question. Time period of 50 oscillations. So what will be the time period of one oscillation? Time period of one oscillation will be equal to 98 divided by 50, and that is 1.96 seconds. 1.96 seconds. Now we have to calculate the value of acceleration due to gravity. From this equation you can calculate acceleration due to gravity, which will be equal to 4 pi square L by T square, correct, by squaring on both sides. And let's substitute values. 4 times pi square means 3.14 square into length is 0.98, correct, 0.98 divided by T square, that is 1.96 square. Length was given as 98 centimeters, so we converted into meter. Okay, fine. Now once you solve this, you get a value which will be equal to acceleration due to gravity 10.06 meter per second square. That is the value of the acceleration due to gravity you are going to get. Next step, we have to calculate with proper error limits, which means we have to find the error in acceleration due to gravity. What is the method? Delta G by G. Delta G by G is equal to delta L by L plus 2 times delta T by T. A similar question you can find in the NCERT book. Okay, so once you substitute, which implies delta G value will be equal to G into, that means this G will go to the right hand side, that is 10 into what is delta L by L? Delta L, for that they have given a hint. The hint is the least count of time is 1 second, and least count of distance, it's 1 centimeter. Okay, that is the hint they have given. So how will you substitute? Yeah, since it is given 1 centimeter as the least count, instead of converting into meter, we can write delta L by L like this, so that conversion will get cancelled. Yeah, then what's plus 2 times delta T, that's the least count in time. Error in time is the least count, error itself is the least count. So 2 into delta T by time. What's the time they have given? 98 seconds. Time is also 98 seconds. So just solving this part, okay, you get delta G will be equal to 0.3 meter per second square. 0.3 meter per second square. So what will be the final value, final result? How will you write the final result? Acceleration due to gravity, you have to write it as G plus or minus delta G. that will be equal to, remember we have to round it, so 10.1 will be the magnitude, plus or minus 0.3 meter per second square will be the final answer. So that's how we calculate the value of acceleration due to gravity with proper error limits. Okay, this question is to calculate the impulse. So just by looking at the graph itself, it's a force time graph. Okay, two things that you have to be always remember is that whenever you see a graph, two things that should come in mind is, one is slope, the other one should be area. Either of these two will be having some significance, will be in the given graph. Okay, in this case the area of this graph is having the significance, and that significance is impulse. Force into time is impulse. So in the given question, a one-dimensional force varies with time according to the given graph. Calculate the impulse of the force in the following time intervals, and how time is varying from 0 to 5, then from 5 to 10, from 10 to 15 is going. So in the first question, the first part, we have to calculate the impulse from 0 to 10 seconds. Okay, we have to calculate the impulse from the time interval 0 to 10 seconds. What do you mean by that? We have to calculate the area of the region. Which region of this part? This region. Okay, this region you have to calculate the area. So what will be that? There is a square along with a triangle. So let's calculate the A part. So area of the square, let me write like this: area of the square plus area of the triangle. This is the area of the triangle. So how will you calculate? Square will be having area, check the units, it's Newton and second, so it's fine. 10 into 5, it's not a square, it's a rectangle, fine, plus, and triangle will be having the area half times base is only having 5 seconds, so half into base into altitude is 10. So what will you get? 50 plus you get 25, which will be 75 Newton seconds as the first answer. I guess it's easy for you. The second part, from time 10 to 15 seconds, you can see a triangle which is beneath. Here you can see a triangle from 10 to 15. This is the area we have to calculate now. So how will you calculate? Half, let me write, area of the triangle. Which triangle? We are considering this triangle now. Okay, which is equal to half times base is once again 5, because this is 5, and altitude, how much it is given? It is given 5. So let's calculate the area. It will be, since the altitude is not given, 1 second, let's take the altitude as 10 for the time being. Let's take the altitude as 10, so half into base into altitude, let's take it as 10. Okay, so it will be 25 Newton second, fine, that's also fine. Now the third part of the question, C part, this we have to be careful, because we have to calculate the total area, because they are asking to measure the impulse from 0 to 15 seconds. So what we are getting, all these values are impulse. Okay, impulse quantities. These are all impulse quantities. So don't get confused. Fine. We are not simply finding the area, we are calculating impulse. So finally, once you calculate the total area, what we have to do? The area of the square plus area of the triangle. Which triangle? The upper triangle, minus area of the lower triangle. That gives you 75 minus 25, which will be equal to 50 Newton seconds. So this is an easy question, but still I took this question in order to give you the concepts or the significance of the area as well as the slope. Now if you do remember, let me ask you a question. What is the slope of the indicator, isothermal indicator diagram? Do you remember? Slope of the isothermal indicator diagram is minus P by V. Minus P by V. What about the slope of the adiabatic indicator diagram? It is minus gamma P by V. So we have graphs in physics that has got the importance to know about slope. We also have graphs that has a lot of importance for area also. So we have to compare graphs and study accordingly. What about the slope of an acceleration time graph? Acceleration time graph slope, you get the quantity jerk. Let me write over here. That quantity is jerk. Acceleration by time is jerk, which has been asked for once in IITs. So velocity by time we know, displacement by time we know, but acceleration by time quantity is called as jerk. So slope of an acceleration time graph is jerk. What about the area of a velocity time graph? Area of the velocity time graph gives you displacement. Area of the speed time graph, area of the speed time graph gives you distance. So all these things, slope and area, in every question with graph, it's important. Okay, this question is regarding collision. Collision is one among the most important topics for the NEET exam. There are two types of collision: elastic collision and inelastic collision. Elastic collision itself can be asked from one dimension or two dimension, and inelastic collision too. There are oblique collisions also. We have perfectly elastic, perfectly inelastic collision cases. We have coefficient of restitution in that thing. So many things can be asked from the topic collision. Collision is more or less related with explosion also, explosion problems. So you have to refer so many questions, not this one question what I am taking in for capsule class. This is just a representation of all those questions, just one small example. That's all it's becoming. So what you have to do is that you have to refer more questions. So let's see this one. A ball of mass 2 kg moving with speed 5 meter per second is colliding directly with another ball of mass 3 kg moving in the same direction with speed 4 meter per second. The coefficient of restitution is given. We have to find the velocities after collision. So let's take two balls. One is 2 kg. So it will be 2 kilogram. It will be a smaller one, and the other one, let's draw it large, 3 kilogram. So let it be 2 kilogram and let this be 3 kilogram. Okay, now initially they are having a velocity, correct? They are having a velocity. Let's write it as UA. The velocity of the ball be UB. Fine. And what is the velocity of UA? 5 meter per second. What about the velocity of the second ball? It is 4 meter per second. We know that collision will happen only if UA is greater than UB. This is the fundamental condition of collision. Okay, the initial velocity of the first ball should be greater than the initial velocity of the second ball. Now, during a collision, we have to calculate the final velocities in this question. During a collision, we know that if it is elastic collision, three things will be conserved. Okay, during a collision, if it is an elastic collision, three things will be conserved. What are they? Momentum. First one is momentum. Then comes kinetic energy, and then comes total energy. These three factors, three parameters will be always conserved. Once it comes to inelastic collision, then only two parameters or two quantities will get conserved, which will be momentum and total energy. Okay, always remember this point. Let's consider this case, the given question, as an elastic collision, and let's do it. So even if it is elastic or inelastic, even though they haven't mentioned this case, we can take the concept of momentum conservation and we can solve this problem. So even though they haven't given whether it is elastic or inelastic, we can solve this problem. So let's don't consider as a default case as elastic. Let's take it as let's take this case as either be elastic or be inelastic. Why? Because there is a coefficient of restitution term has given. So if it is a perfectly elastic collision, that coefficient of restitution term, what is coefficient of restitution? Coefficient of restitution, E, small e, denoted as the relative velocity after collision, that is Vb minus Va, divided by relative velocity of before collision, that means Ua minus Ub. This fraction or this ratio is called as coefficient of restitution. Okay, now there are two cases when it is perfectly elastic collision and there is perfectly inelastic collision. What will happen in a perfectly elastic collision? This E value will become 1. That is a speciality of the coefficient of restitution term. For a perfectly elastic collision, let me write here, perfectly elastic collision, the E value will be equal to 1, and for a perfectly inelastic collision, E value will be equal to 0, which means after colliding, the relative velocity after collision will become 0. Okay, that is the speciality of perfect inelastic collision. Now it's a value between 0 and 1, which means all other cases will be having the coefficient of restitution value between 0 and 1. Okay, let's get into the question. Let's take the momentum conservation principle, that is the momentum before collision, which is MAUA plus MBUB equal to MAVA plus MBVB. That's the momentum conservation equation. Let's substitute values because they have given values as mass of the first particle 2 kilogram, correct? Mass of the first particle, yes, 2 kilogram into UA is given 5, plus the MB is given 3 kilogram into UB is given 4, equal to MA, once again 2, we don't know about VA, and MB is 3 kilogram, and VB we don't know that. So we get an equation. Solving this equation, you get 3VB, okay, plus 2VA. 3VB plus 2VA, you will get 22. That's the first equation. Fine. Now we need one more equation to solve for VA and VB. Which equation we can substitute? We can take the coefficient of restitution formula. Coefficient of restitution is already given. E value is given, which is 2 by 3. So 2 by 3 will be equal to VB minus VA divided by UB minus UA. What is UB minus UA? It's given UA minus UB, which is 5 minus 4, from which you get the second equation, VB minus VA will be equal to, okay, by solving this equation you get VB minus VA will be equal to 2 by 3, which is the second equation. Solving this first and second equation, you get VA value, velocity of the first particle after collision, it will be 4 meter per second. Velocity of the second particle after collision, you get 4.67 meter per second. That's how we do this problem. So in this question, you can see you might already have heard about coefficient of restitution, but this term is very important for problems regarding collisions. Okay, in this question we have position vector r of a particle varies with time t according to the law r equal to half t square I minus 4 by 3 t raised to 1.5 j plus 2t k, where r is in meters and t is in seconds. Find the suitable expression for its velocity and acceleration as a function of time. Also find the magnitude of the displacement and distance traveled in the time interval 0 to 4 seconds. This is the question. Now, this question, if you can solve it, then you are good in integration and derivation, because for the NEET purpose and JE purpose, slightly much more difficult derivations you can expect, or integrations you can expect. But for a NEET level, if you can solve this question, yes, you have definitely got the concept of this calculus part. So what they are asking, they have given a function. What is that function? That function is clearly given in the question, which is r equal to half t square I plus 4 by 3 t power 1.5 j plus 2 tk. First we have to calculate a suitable expression for velocity and acceleration. If a position vector is given, how will we calculate the velocity? Velocity is equal to change in position by change in time. Remember, velocity is a vector quantity. Position, change in position by change in time. Okay. Now we have to take the derivative of the position vector. Now carefully you have to take the derivative. Why? Because the given terms are like that. So it's d by dt. Let me write the entire term, that's better. D by dt half t square I, okay, half t square I minus 4 by 3 t power 1.5 j, okay, plus 2 tk. Those who are finding still difficulty in derivation, just pay good attention. What is the derivative of half t square I? Half you can take constant outside, okay. Derivative of t square is 2t, okay, and the remaining term is I cap. Next term, derivative of minus 4 by 3 t raised to 1.5 j. So once again constants out, so minus 4 by 3 is out. Derivative of t power 1.5 is 1.5 times t raised to 1.5 minus 1 times j cap, plus derivative of 2tk cap is 2k cap. Now let's reduce this term. So 2 get cancelled, you get t times I cap and 1.5. This 1.5 is 3 by 2. So this 3 and this 3 will get cancelled, and 4 will get cancelled with the 2. So you get minus 2t. 1.5 minus 1 is 0.5. 0.5 means 1 by 2. 1 by 2 means root t j cap plus 2k cap. Did you get this? So that's how we take the first derivation. That's velocity. Okay, that's a velocity term. So let's write it as meter per second. We got velocity. Now what's the next step? We have to take the derivative once again to find the acceleration. So d by dt, derivative of the given term above, that is t I cap minus 2 root t j cap plus 2k cap. So what will you get the derivative? Once you take the derivative, you get the derivative of t I cap, you get I cap, minus 2 root t j cap derivative. What will you get? Take the constants out. So minus 2 is a constant, it is taken out. Derivative of root t is equal to derivative of t raised to 1 by 2 is equal to 1 by 2 times t raised to 1 by 2 minus 1 j cap. Derivative of 2k cap is 0, so let's leave that part. Now this 2 will get cancelled, and what you get? You get I cap minus 1 by root t j cap into j cap. Understood? That's how we do this. Unit is meter per second square. So you get acceleration term. So you get acceleration here and you get velocity over here. Fine. Now what's the next question? That's the first part of the question. Find the magnitude of the displacement and distance traveled in the time interval 0 to 4 seconds. Okay, that's the next part. We have to calculate the displacement. We know that the displacement is the change in position. So from t equal to 0 to 4 seconds. So first of all, let me write the position vector once again. Because position vector itself is given as a function of time. So we have to substitute. Let's write the position vector first instead of more confusions, let's write it again. Half t square I cap, okay, minus 4 by 3 t power 5 j cap plus 2 t k cap was in the given question. Is it correct? Half t square I cap minus 4 by 3 t power 1.5 plus 2 t k cap. Yes. Now we have to calculate the magnitude of the displacement, right? So let's calculate the displacement. Let's calculate the displacement. Displacement from t equal to 0 to t equal to 4 seconds. T equal to 4 seconds. So we know that the position vector at t equal to 0, by substituting t equal to 0, you get the entire term as 0 only. You have nothing to do in that. So what about the position vector at t equal to 4 second? At t equal to 4 second, you have to substitute half, okay, half into 4 square, that is 16 I cap minus 4 by 3 t power 5, that is 4 power 5 j cap plus 2 into 4 k cap. Understood? That's how we do it. So what will you get? Once you solve this, you get 8 I cap, okay, 8 I cap, then you get minus t equal to 4 second, you have to substitute, so minus, you get 32 by 3 j cap plus 8 k cap. Okay, hold a second. In this question, 4 by 3 t power 1.5, 4 by 3 t power 1.5, yes, it's 1.5, 4 power 1.5, then only you will get 32 by 3. Fine. Now that is the vector term. Now the difference between this is the displacement. So once you subtract the position vector at t equal to 4 with position vector t equal to 0, you get the same answer, but then you have to calculate the magnitude of it. So delta r. So what is the magnitude of this vector? Root of 8 square plus 32 by 3 square plus 8 square. So that's what you get, the magnitude, which will be equal to 15.55 meter. So the question is to calculate the magnitude only, that is displacement. Now what about distance? How will you calculate distance? So let me write distance, because we have to calculate the distance also. Now this is the tricky part. Distance is a scalar quantity. So you might think, how will we already calculated displacement from t equal to 0 to 4. We have to calculate distance in a different way. Okay, we know that distance is equal to integral of velocity from t equal to 0 to t equal to 4. This is something that we have to do, so be careful. So it's not the change in position you get the displacement, because the displacement is not depending upon the path, it only depends upon the initial and final point. So we simply calculated the position vectors at t equal to 0 and t equal to 4, and we just subtracted it. But distance depend upon path, so we have to take the integration of velocity, which is equal to integral t equal to 0 to 4. What is a velocity term? Velocity term, velocity term, and this is something mathematical trick what we have to do here. Let's take the velocity term from above, which is ti minus 2 root tj, correct? Ti minus 2 root tj plus 2k. This was the velocity part. Now what I'm going to do is that to dt. What we are going to do is that we know that distance is a scalar quantity, so there is no meaning in writing it as a vector form. So we have to take the magnitude of this quantity. How will you take the magnitude of this quantity? Which is root of a square t square, okay, plus 2 root t square, 2 root t square plus 2 square plus 2 square, okay, plus 2 square dt. Since distance is a scalar quantity, that's how we do it. Then what will we get? We get integral t equal to 0 to 4, integral t equal to 0 to 4. We can write this as t square plus 4t. Okay, be very careful. 4t plus 4 dt. Am I right? Now, what else next you can do? Integral t equal to 0 to 4. What is this term? It is root of t plus 2 whole square dt, which is equal to integral t equal to 0 to 4 t plus 2 dt, which is equal to the integral of this term will be equal to t square by 2 plus 2t within the limit 0 to 4. Substituting the value, substituting the limit, you get 16 meter. Now what was the displacement quantity? It was 15.55 meter, and distance is more than that, so it is correct. So that is how we do the distance. We should not treat it as a vector quantity. We have to take the magnitude of it and we have to proceed accordingly. Then only you can calculate the distance. So you might think that the calculation of distance is easy, but it's not so easy. We have to be very careful. So we calculated velocity, acceleration, magnitude of displacement, as well as distance. Hope you got this. Okay, this question is related to laws of motion, where you can see a block actually tied up with 2 ropes, and we have to calculate tensions, we have to calculate the angle, everything. Okay, so let's read the question, the part A. A box of weight 10 root 3 Newton is held in equilibrium with the help of 2 strings OA and OB as shown in the figure. The string OA is horizontal, and find the tensions in both the strings. So let's focus the first part alone. Let's read the second part after doing the first part. In this question, it's clearly given that the weight 10 root 3 is acting exactly down. So let me draw over here 10 root 3 Newton. The weight is acting exactly down. Now a rope is connected OB, and the angle is 60 degree. So look at the figure, the angle is 60 degree, which is connected with the ceiling. So when I draw that 60 degree over here, it will come here, alternate angle 60 degree. I hope you understood. Now tension will be always acting upwards through the string. So let me mark tension here, which is T2. Now there is another tension which is acting horizontal, okay, which is acting horizontal, and that is T1. So T1 is acting in this direction. T1 is acting in this direction. We have to calculate the tension. 2 tensions, it's easy. How will you calculate? We can calculate tensions by taking the components. If you remember how to calculate the components, it's very important. So here the horizontal component of T2 is T2 cos 60. The horizontal component is T2 cos 60, and vertical component is T2 sin 60. T2 sin 60. You should have a very good idea about taking the components. So horizontal and vertical component we wrote. Now what we have to do? We have to simply equate. How will you equate? T1 equal to T2 cos 60. T1 equal to T2 cos 60, and T2 sin 60. T2 sin 60 equal to 10 root 3. 10 root 3. So what will be, these are the 2 equations, and we can solve these 2 equations to find out the value of T1 and T2. What will you get? T2 sin 60 means root 3 by 2 equal to 10 root 3. Root 3 will get cancelled to get T2 equal to 20 Newton. That's the first part. Then T1, if T2 is 20 Newton, then T1 equal to 20 cos 60. Cos 60 is 1 by 2. So you get 10 Newton. So T1 will be equal to 10 Newton. So that part is easy. There is no much confusion in that. Now let's focus the second part. If you can change the location of the point A on the wall and hence the orientation of the string OA without altering the orientation of the string OB as shown in the figure 2, what angle should the string OA make with the wall so that a minimum tension is developed in it? Okay, you can pause this video and you can read that question once again. I'll summarize that question that the OA is now altered without altering OB. Okay, you have to calculate the angle theta so that the tension through that string, through the string OA should be minimum. So what angle you should keep in order to get the minimum tension in the string OA? That is a simple question. Okay, now let's solve that part. Now how will you do that? So for that, let me draw the x-axis, y-axis. Fine. Now how we can solve this issue, or how we can solve this problem? Let's draw 10 root 3 as we have drawn before, exactly through the negative y-axis. Then there is a tension acting in through the string through OB. It is T2, and this is 60 degree and this is 30 degree. Fine, there's no confusion in that. Okay, now let me draw T1. T1 will be something like this. I don't know that angle, so T1, let's mark an arbitrary angle theta. Where will be that theta? The theta will come over here. Okay, if you have doubt, let me show the figure. Theta is here, right? So once you draw the free body diagram, theta will come here. So that's what I have drawn here, and T1. Yes. Now we can write the equations. What is the horizontal component of T2? T2 cos 60 and T2 sin 60. T2 sin 60 is also equal to T2 cos 30. Remember that. So you can take either of these two. Okay. Similarly, we have horizontal and vertical component for T1, which will be T1. Remember, theta is here now. Now theta is here. The inner angle is theta. So horizontal component will become T1 sin theta, and vertical component will become T1 cos theta. Understood? That's how we do it. Now let's equate this. How will you equate this? Let's equate the left side component, which is T1 sin theta, will be equal to right side component, which is T2 cos 60. T2 cos 60, that's one equation. What is the second equation? Components which are going up. Which are they? T1 cos theta plus T2 cos 30 or T2 sin 60, whichever you want, you can take that. T2 sin 60 I'm taking for the time being, equal to 10 root 3 is the second equation. Understood? So that's how we do this. So the remaining part, let's simply solve these two equations and you can calculate the value of T1 and T2. But there is something remaining. You have to find the minimum tension value. Understood? Minimum tension value, because you cannot simply solve this. Why? Because there are three unknowns. We need three equations to solve three unknowns. Which are the three unknowns? T1, T2 and theta. So you can solve this. You will come to an equation for T1 which will be equal to 10 root 3 divided by root 3 sin theta plus cos theta. This is where you will come to a stop, because we can't further proceed without getting another equation. But they have given something else, that T1 value should be minimum. In order for T1 value should be minimum, what should be theta? That is the question. In order for T1 to be minimum, the denominator should be maximum. Correct? The denominator should be maximum. So when will this denominator will become maximum? Just think that the maximum value of this, when will this denominator will become maximum? The maximum value of this term is 2. Maximum value of the denominator, which is root 3 sine theta, root 3 sine theta plus cos theta is 2. This is the maximum value, is 2. So from which you can calculate root 3 sine theta. Okay, root 3 sine theta plus cos theta equal to 2, and theta you get 60 degree. Okay, so the question you might, or the doubt you might be having is how the maximum value of root 3 sine theta plus cos theta is 2. Just think about it, and let me do that in other page. So just pause the video and think that for a second, how you can get the maximum value of the denominator is 2. Okay, so in the previous problem, the confusion was about how we will get the denominator term maximum value as 2. Let me solve that. We know that the denominator should be maximum, correct? Root 3 sine theta plus cos theta was the denominator. Root 3 sine theta plus cos theta. In order for this term to be maximum, we have to bring the concepts of mathematics. We have to take the derivative of this term and we have to equate that to become 0. D by d theta should be 0. This is the condition for maxima. As well as for minima also, we take the first derivative and we equate it to 0. We take the second derivative also. That is the part of maxima minima calculation in mathematics, which you don't have to bother much in physics. If you come into a situation like this in physics, what you have to do is that you have to take the first derivative equal to 0. Okay, even if it is maximum or even if it is minimum, this is what you have to do. Now what is the difference, if you might be thinking? That's why I said the explanation goes in mathematics. The first derivative you have to take it as 0. The second derivative, if it is negative, then it is maximum. Second derivative, if it is positive, then it is minimum. We call it maxima minima. Okay, whatever. Here we have to find the value of theta to get this term to be maximum. So derivative of root 3 sine theta is what? Root 3 times cos theta. Derivative of cos theta is what? Minus sine theta. This should be equal to 0. So what will you get? Sine theta by cos theta equal to root 3. Correct? That is tan theta equal to root 3. Tan theta equal to root 3. Which means theta will be equal to 60 degree. Why? Because sine 60 by cos 60. Sine 60 degree by cos 60. Sine 60 is root 3 by 2. Cos 60 is 1 by 2. And that gives you root 3. Okay, this is one way to solve that problem. So that you can see over here, the value of theta is 60 degree. So at theta equal to 60 degree, you get the minimum tension in the string OA. That's how we will complete that problem. So previously I said that I brought into a pause that how to do that particular part, and now I explained that how to calculate theta in order to get the maximum. So in order to get the minimum tension, you should get maximum denominator. Okay, so that comes to a conclusion of today's capsule classes. And for the time being, what I'm going to do is that I'm going to give you an assignment. So just look at the question and try to solve it yourself, which I will be giving the answer in the next capsule class part. Okay, thank you.